Hi, I'm Henderson with Team 12. I'm going to be talking about my project of building a GDB Remote debugger. So the first question we have to ask is, why do we want to use GDB anyway? Well, as you know by now, we can use the debugger to see what's going on to our program while it runs. We can watch variables, set breakpoints, and see the state of our program at particular times, and even change values if we want to see what happens or try to force a bug to occur or something like that. But the other question that we have to ask while looking at implementing the GDB Remote debugger in our kernel is, why not just use QEMU GDB? Well, the answer first off is that multi-architecture stuff is weird. Trying to emulate AArch64 on top of x86 and then interact with it over x86 again results in some kind of odd happenings sometimes. QEMU oftentimes has different bugs than on the Raspberry Pi. There's been plenty of times that I've had a bug happen only on my Raspberry Pi but not QEMU, which makes it extremely difficult to debug if it's happening in one place and not the other. But the more important part of why we want to implement the GDB remote stub is because QEMU doesn't run on our Raspberry Pi. Well, yeah, I'm sure some of the people with the other projects will get that working eventually. But we want our Raspberry Pi to be doing as much as possible itself. So what do we need to do to implement the GDB remote stub? Well, we need exceptions and interrupts, and then we also need communication between the stub and the host computer. Luckily, Lab 4 is all about exceptions and interrupts, so there's not a lot extra that we have to do there to get the GDB remote stub up and running, but there will be plenty that we have to do later if we want some of the more advanced features. For communication, we have to implement the GDB Remote Serial Protocol, which is a standard set of packets and commands and data transfer designed by GDB to communicate between stubs and the server. Through that, we'll have to implement a few commands like continue running the program, step forward one instruction, read and write memory and registers, set and clear breakpoints, and set and clear watch points. The difference between watch points and breakpoints, if you didn't know, is that breakpoints are for at a particular point in the program, like before a particular instruction runs, while watch points are pause the program when a variable changes. So that's very useful if we want to watch a particular value, see if it ever changes and when it changes and things like that. In addition, the remote serial protocol also has some metadata, such as what the stub is capable of, and it also has checksums on every packet that we'll need to calculate. The meat of the project is going to be in the other features that are much more outside the scope of Lab 4. In particular, breakpoints and watch points using the ARM hardware. ARM actually specifies hardware registers that you can set up for breakpoints and watch points. You can set what address you want for your memory instruction, what memory address you want for a particular instruction, and it will automatically trigger an interrupt once you hit that point. So you just set that into a register, a breakpoint register. The same thing happens with watch points. If you set the address of a memory variable, in memory, and then when that changes, it will automatically trigger an exception, and you can see what the variable changed and everything. Another thing that we will want to implement is Control-C interrupts. If you press Control-C while your program is running on GDB locally, then the program will pause immediately and you can see what's happening at the moment, which is good for while true loops where you don't know how you got into that state or what it's currently working on. To do that, we'll probably need to have multiprocessing and time sharing, but it'll have to be so that one process is listening for the Control-C over the serial connection while another process is actually running. So Control-C will have to interrupt, and then we can look at the other process and see what's going on. We will also want to implement debugging child processes so that we can use our multiprocessing implement in Lab 4 to its full capabilities so that we can spawn one program and then spawn another child program from that and debug the child program just as well as we can debug the parent program, so that we can have GDB in user space basically. In addition, one thing that we may want to implement would be GDB not in the kernel, so that, for example, if you connect your Raspberry Pi over a serial connection and open up GDB and connect to it over the serial connection, you don't connect to the kernel. You can't just look at what's going on in the kernel. Instead, you're looking at the user space program and what's running there. That will require some interesting work. I'm not sure exactly how we go about doing that, but it's something to work on before the end of the semester. So again, I'm Dennis Henderson with Team 12, and this is my project of GDB Remote Debugging. Thank you.